In this video, you will gain an understanding of what regression analysis is. Let's start with two simple scenarios. First, imagine you're a school principal. You're thinking, if I reduce class sizes by hiring more teachers, will students actually perform better? This question is about causal inference, understanding how one variable affects another. In this case, the principal wants to know whether class size, the independent variable, usually denoted by x, has an effect on test scores, the dependent variable, usually denoted by y. Our goal is to quantify that effect. Now, imagine you're on the other side of the table, a parent looking for a good school for your child. You might ask, if I move to a district with smaller classes, can I expect higher test scores for my child? This is a question about prediction. Given the value of x, class size, what value of y, test score, should we expect? Regression analysis is a statistical tool that helps us answer both types of questions. 1. Causal inference, and 2. Prediction, by using real-world data. Suppose you collect data on class sizes and test scores. You plot these data points on a scatter diagram with class size on the x-axis and test scores on the y-axis. What regression analysis does is to draw a line through the data that captures the average relationship between these two variables. Mathematically, this model is written as test score equals beta 0 plus beta 1 times class size plus UI. Here, the model is describing how the average test score varies with class size. If your data set included every school in the entire population, this would be called the population regression model. We'll explore the difference between population and sample models in later videos. Here's what each term means. Beta 0 is the intercept, where the line crosses the y-axis when class size equals 0. Beta 1 is the slope. It shows how much the average test score changes when class size increases by one student. UI is the error term. It captures all other factors that affect test scores but are not included in the model, such as differences in teaching quality, student ability, or parental involvement. For example, suppose our regression line predicts that when class size is 5, the average test score should be 70. This is the conditional mean, written as the expected value of test score, given class size equals to 5. But suppose in the data, the district with class size 5 actually scores 60. The difference, 10 points in test score, is the error term, UI, the part of the outcome that the model doesn't explain. So, to summarize, regression analysis is about finding the line that best summarizes the relationship between two variables. It can be used to estimate causal effects or to predict outcomes, depending on the question we want to answer.